My name is Bart Lenart. I am an associate librarian at the University of Calgary, where I'm the subject librarian for education and philosophy. Before starting my current position with libraries and cultural resources at the U of C, I taught philosophy at the University of Alberta. One of my research interests while at the U of A focused on computational theories of mind. It's with this background and my work around the extended mind thesis and extended identity that I offer some philosophical musings on the topic of AI and academic integrity. This presentation will argue that as generative AI becomes more and more autonomous in the generation of content and in its own learning, we will need to start shifting our attitude toward it by habituating ourselves to treat it and the ideas it generates less and less as a tool and the products of a tool and more like an autonomous collaborator, akin to how we treat the contributions of colleagues in the context of research, collaborations, or fellow students in the context of coursework. In order to accomplish this, I will introduce two philosophical ideas that will help make this case. The first idea is the notion of the intentional stance, first introduced by philosopher Daniel Dennett. Dennett argues that in order to make quick and accurate predictions about the behavior of people or other entities, evolution has endowed us with the ability to adopt a predictive strategy that imputes rationality to the world around us. This includes other people, but is also true for non-conscious processes like complex computations. I will explore this idea through an analysis of how humans play chess against computers. The second philosophical idea that will help me make my argument is the thesis proposed by philosophers Andy Clark and David Chalmers, which argues that the introduction of tools and technologies has allowed for the offloading of cognitive tasks. This has been dubbed in the literature as the extended mind thesis. One simple example of such offloading, one that I'll discuss later, is the case of relying on a calculator to multiply numbers while solving a larger problem. The use of the calculator literally extends the cognitive process to encompass the neural activity involved in the problem solving, as well as the electronic system encased in the calculator. But environments themselves can function as systems for cognitive offloading as well. When navigating a trail, for example, hikers need not rely on internal memory and processes to map the environment, as such mapping can be offloaded onto environmental markers and landmarks. Again, the idea is that evolution has equipped us with the ability to incorporate the environment to offload the enormous costs of cognitive processing in order to help us think faster. This, however, also implies that processes involved in thinking need not be solely based on brain activity, that is, the firing of neurons, for example, which further suggests that some instances of processing that occurs with the aid of, say, silicon chips, as in computer processes, can legitimately be considered functionally akin to thinking. So when we say that the computer is thinking when we're waiting for it to do something, there may be some cases where this is literally functionally accurate. There has been much discussion about the exponential growth of the capabilities of generative artificial intelligence. Currently, however, even our most powerful attempts at AI have been narrow in nature, meaning that they are purpose-built for specific tasks. This is also known as weak AI. One example of powerful weak AI are chess engines like Houdini, AlphaZero, Stockfish, and there are others. While these programs utilize reinforcement learning and self-play to train their neural networks, and so have become autonomous learners, their sole focus on one particular task, in this case playing chess, makes their application narrow in scope, as the neural networks are only trained for that particular task. Strong AI, on the other hand, would behave and learn much more like a human being does, by generalizing much of the training the neural nets achieve by adapting learning from one task to another. General or strong AI does not exist yet, and it's not clear that it is something that can be achieved. Nevertheless, the autonomous processes of deep learning, which utilizes the training of neural nets, may one day lead to the development of general AI. As already mentioned, one famous example of narrow but very powerful AI are the many chess engines that continue to become more and more powerful through self-play and interaction with other chess engines. The chess engines of today are so powerful that no human player can ever hope to beat them at the game of chess. In fact, since 2010, chess AI have had dedicated chess competitions known as the Top Chess Engine Championship, where the various chess AI compete for the title of world's strongest chess player. Obviously, human players continue to take part in human-only tournaments, since the gap between AI and human capacities in this narrow endeavor has grown beyond the possibility of bridging. While AI like ChatGPT appear to have a more generalized scope than engines like Stockfish or AlphaZero, they are nevertheless still considered narrow or weak AI. As this presentation will argue, however, this does not change the fact that as such programs become more and more powerful, even in their narrow or weak manifestations, our interactions with them will need to shift dramatically. For example, while Stockfish or AlphaZero can be and are utilized as training and analysis tools, the autonomous nature of their deep learning makes them more than mere tools. When playing one of these chess engines, a player must adopt what philosopher Daniel Dennett has dubbed the intentional stance towards the chess engine. Now, it's true that the computer does not think in the way a human player thinks, and it does not share the human motives or goals to play the game. Nevertheless, a human player must impute a specific type of thinking and motivation onto the computer opponent in order to engage it in a competitive match. Daniel Dennett argues that the human player has to assume the intentional stance toward the computer program and treat it as though it were a human player with human ambitions regarding the outcome of the game. That is, when the computer moves a certain piece, the human opponent cannot respond by trying to figure out what the weightings of each branch of the computer's decision tree might be, since such brute force calculations are impossible for human minds to explore. Rather, the human player has to approach the move as though it was made with the sort of intention a human would have put behind their own move. In playing a computer, one might have reactions like, "What are you trying to do with your rook? What are you planning with this opening?" and so on. And while there is in fact no trying or planning in the way that humans try or plan, the attributions of such motives and goals are perfectly appropriate here. The idea then is that there was a moment in the history of such programs where they have ceased to be mere tools and have become autonomous entities, albeit in the narrow sphere of their specialized application. The key notion here, however, is their autonomy. Because such programs no longer rely on humans for evaluations or inputs regarding what constitutes the best move, they have not only become unpredictable, but have also managed to surpass the human capacity to play and analyze chess. And both are reasons why utilizing a chess engine while playing against a human opponent is considered cheating in the chess circles, while utilizing a calculator to aid in computations is not considered inappropriate in mathematics circles. The main difference here, I wish to argue, is that in the latter example, a calculator merely ensures the accuracy of the results, but does not contribute to the cognitive process of solving a particular math problem. The case of using the chess engine to aid in choosing the best moves on the chessboard, on the other hand, is literally a case of employing the aid of an autonomous process, not unlike, if we are forced to adopt the intentional stance, that of an unnaturally capable human. There's a bit more to this idea, however. So let me briefly introduce the extended mind thesis first introduced by Clark and Chalmers in their 1998 paper. The extended mind thesis states that cognition literally extends beyond the skull. One very simple example of this is using paper and pencil to do long division. Some of the operations occur in the brain, but some of them are offloaded onto the paper, only to be taken up again when the processes occurring in the brain have need of it. Now, this isn't just a case of offloading memory, since the operations themselves are performed on the paper. Other familiar examples that involve memory offloading are using our phones to remember phone numbers, or using calendars or agendas to remember important dates or appointments. In the calculator example, The cognitive process of solving the math problems is entangled with the computational process taking place within the calculator. And since not all cognitive processes need be conscious, the computations taking place within the calculator are functionally no different than if these same computations were performed with the aid of neural networks in the human brain. The difference, according to Clark and Chalmers, is that those computations were offloaded to the calculator, and thus the cognition involved in solving the math problem incorporated the physical process within the calculator, thus extending the process beyond the mathematician's skull. According to the extended mind thesis, then, the calculator in the math problem example can actually be understood as part of the human problem solver's own cognitive process, while the chess playing engine has to be understood as a separate cognitive process employed to aid in the decision making of the human problem solving process. And this is why the latter type of computational aid is considered inappropriate in the context of the narrow application to chess, while the first does not strike us as problematic in the narrow application to solving math problems. It might be argued that generative tools like ChatGPT, while not conscious, could be thought of as extensions of our own cognitive processes, similarly to searching a database as part of the research process or using a citation manager to organize our thoughts. The problem with this line of thinking is that programs like ChatGPT are generative in a way that a database, a citation manager, a calculator, or a spell checker just aren't. Rather, ChatGPT is better understood as a contributing source of generative cognitive processing, just as a chess engine would be when employed to aid in a game of chess between two human beings. And the more we move toward general AI, or at the very least, the stronger our narrow AI become, the more the term cognition may be applicable here. It may well be time for us to start thinking about adopting Dennett's intentional stance in anticipation, as it were, of a time when the collaborative efforts of humans and generative AI will be very commonplace. And getting into the habit of attribution as collaborator may make navigating questions of ethics a little bit easier. If a student, for example, uses AI to write a paper without proper attribution, we can in fact call that collusion, as it is functionally similar to inappropriately collaborating with a human or to buying a paper from a paper mill. Similarly, writing emails to students using AI may start looking inappropriate if we would deem it inappropriate to have an assistant write them. Where that practice is allowed, then generating emails would be acceptable. But where that practice seems unethical or immoral somehow, as in cases of maybe sending personal messages, separating one's own voice from the generative voice of the AI by adopting the intentional stance helps us sort out when and where it is appropriate to use the tool as a tool and where it's not appropriate to rely on the tool at all. In an interesting twist, and in a real sense, by adopting these practices, we start respecting the AI's autonomy as well. And if general AI becomes a reality, and if it will truly be autonomous, even if never in the way that a human would be, then respectful dealings and interactions with such entities might become more and more appropriate as well. This is a bit beyond the scope of this presentation, but those will have to be questions we will need to ask at some point. Now, some researchers suggest that we will have general AI within 10 years. While that may be a bit optimistic, general AI is nevertheless a very real future possibility. Because cognition need not be conscious, and because, as the extended mind thesis suggests, it need not even be generated by the human brain, it is not inappropriate to consider computational processes at least functionally akin to thinking. And if we adopt the intentional stance toward autonomous processes like deep learning, then the distinction between what we consider to be thoughts, reflections, educated guesses, arguments, deductions, and so on, in the context of the human researcher's cognitive endeavors becomes much less pronounced when a generative AI performs them. In light of this understanding, functionally speaking, the difference between unattributed aid from a human mind and similarly unattributed employment of a generative AI becomes so minimal that both can be viewed as instances of inappropriate collaboration or collusion. Just as we engage in the practice of attributing words and ideas to people, so we should start getting into the habit of doing the same when the words and ideas are generated by an AI. And I think since we attribute, at least in part, out of respect for the individuals who have uttered the words or had generated the idea that we cite, when we start forming the habit to attribute to AI in the same manner, we inevitably also begin to form the habit of respecting the robots with whom we will be sharing our social and intellectual spheres more and more in the years to come. Thank you very much for your time. You can find my contact information on this slide if you wish to contact me. I look forward to hearing from some of you, hopefully. Thank you.